Hello everyone, today I am here to take discussion on the topic setting reaction of dental amalgam restorations. So before we proceed, let us first see the metallurgic phases or the different phases which were being found on the setting reaction of amalgam restoration. So this includes gamma phase, that is silver tin, gamma 1, silver mercury, gamma 2, tin mercury, which is the weakest, being least stable to corrosion, epsilon phase, that is copper and tin, and eta phase, that is copper and tin, which is the strongest. As we know, dental amalgam restoration, it can be divided into low copper and high copper based on copper alloys. So here first we are seeing the reaction of conventional low copper alloys. So when silver and tin alloy is being mixed with mercury, there occurs dispersion of silver and tin particles into the mercury. At the same time, mercury will start to dissolve silver and tin alloy. So the reaction product, what we can see here is gamma phase, that is the unreacted silver and tin alloy, gamma 1, that is silver mercury, and tin mercury, that is the gamma 2. We can understand this in next slide. We can appreciate here in diagram. Here there is presence of silver tin alloy like this, and here there is presence of mercury. So when the silver tin alloy is mixed with mercury, so silver and tin, it enters into the mercury. At the same time, mercury will start to dissolve silver and tin. So the initial reaction product, what we are going to form is in the form of gamma 1 crystals around the unreacted silver tin alloy. Now as soon as more and more reaction product is being consumed, or as the reaction proceeded, so there occurs more and more formation of gamma 1 crystals. Also there is formation of gamma 2 crystals. So we can say that the set structure, it consists of unreacted silver tin alloy embedded in the matrix of gamma 1 and gamma 2 alloy. Now the drawbacks of low copper alloys, this includes the formation of gamma 2 phase, which makes it least stable to corrosion. It decreases the strength and it makes the restoration margins more prone to fracture. Next we will see the high copper alloy, and this first is admixed high copper alloy. Admixed amalgam alloy, they were introduced in 1963. They were made originally by mixing 1 part of silver copper alloy, that is eutectic and spherical. Eutectic means that is exhibiting complete liquid solubility but limited solid solubility. So here 1 part of silver copper spherical alloy eutectic is mixed with 2 parts of lathe cut silver tin alloy. So when admixed amalgam alloy is mixed with mercury, the initial reaction is the same as for the low copper alloy, that is there occurs formation of gamma 1 and gamma 2 phases. We can understand this in next slide. Here we can see 1 part silver copper eutectic spherical alloy, and there is 2 parts of silver tin alloy which is lathe cut. Here there is presence of mercury. So as the reaction is proceeded, there occurs formation of gamma 1 phase and gamma 2 phase. This occurs because in the initial stages there occurs only dissolution of silver and tin component into the mercury, and also among the silver copper only dissolution of silver occurs. Dissolution of copper, it occurs in very less amount. So the reaction product what we are going to form is gamma 1 and gamma 2 along with unreacted silver copper and unreacted silver tin. Now as the reaction is proceeded in the later stages, all this gamma 2 phases, this were being replaced by the copper which is unreacted. So the unreacted silver copper, when it comes in contact with tin mercury phases, there occurs formation of crystals of Cu6SN5 along with gamma 1 phases. We can appreciate here Here there is presence of unreacted silver copper alloy surrounded by the meshes of Cu6SN5 crystals. We can say that the final set amalgam restoration, it consists of unreacted silver copper alloy surrounded by the meshes or the rods of Cu6SN5 crystals, and they are being embedded in the matrix of gamma 1 alloy. Also there is presence of epsilon phase in smaller quantities. Coming to next, single compositional alloys, they are also being called as non-gamma 2 alloy or unicompositional. Non-gamma 2 because there is no formation or very limited formation of gamma 2 alloy. The major component, it includes silver, copper and tin in uniform composition, all in eutectic form. The copper content, it ranges from 13 to 30% by weight. Reaction we can see here is when silver, tin and copper, that is eutectic, is mixed with mercury, we are going to see the reaction product in the form of gamma 1 and Cu6SN5 phases along with unreacted silver, copper and tin. We can understand this here in diagram. There occurs formation of Cu6SN5 crystals or the rods of Cu6SN5 around the unreacted silver, copper and tin phases, and they are being embedded in the matrix of gamma 1 phases. The difference here between admixed and unicomposition is that we can see here there occurs more and more deposition of Cu6SN5 crystals around the unreacted part of the setting reactions, so thus making it unicompositional alloy more stronger. Thank you.